Where'd the moon come from? It seems like the kind of thing we'd know, right? Considering we've sent spacecraft to the edge of the solar system and found black holes in the middle of galaxies, we should know all there is to know about the rock in the sky. If you went to school in the last few decades, you probably learned that around 4.5 billion years ago, a Mars-sized object collided with Earth. And this epic collision ejected parts of both objects into space, where they coalesced into the moon. That Mars-sized protoplanet even has a name: Theia. And there's a lot of evidence to support this hypothesis. But the theory is not without its problems. It turns out that the origin story of our moon is murkier than you might expect. The Theia impact scenario theory first gained traction in the 1970s, soon after humanity got its first good up-close look at the moon and was able to study it for the first time. One of the striking things we learned was that while the Earth has a solid iron core, the moon doesn't. The impact theory suggests that a collision occurred early in Earth's history, but after most of its iron had sunk to the center. In that case, the debris ejected from the impact would have come mostly from Earth's rocky, iron-deficient mantle, creating a moon composed of mostly lighter elements. And that's exactly what appears to have happened. Earth has a mean density of 5.5 grams per cubic centimeter. The moon, however, is 3.3 grams. This difference is the iron. Considering that the early solar system was probably populated with rogue protoplanets, the possibility that one of them would cross paths with Earth seems likely enough. But here's a wrinkle. If Theia collided with Earth, you'd expect that the moon would also include bits of Theia, with different chemical compositions than what's found on Earth. And that's not the case. Analysis of moon rocks collected by Apollo astronauts shows that, geochemically speaking, the mantles of the moon and the Earth are nearly identical. This makes the collision theory a little harder to understand. But it's still the leader of the clubhouse because, while there's a lot of other hypotheses, they're full of holes as well. There's the capture theory, in which the moon was roped in by Earth's gravitational pull, similar to how Mars captured its two moons, Phobos and Deimos. But these moons were probably just large asteroids that fell into Mars' orbit. This seems like an unlikely scenario for our moon, which is huge and spherical, and it also doesn't account for the similarities in chemistry. Then there's the co-formation theory, which suggests that the moon formed in tandem with the Earth, each morphing out of the same basic materials. But this doesn't explain why the moon lacks iron and is less dense than Earth. The fission theory posits that Earth was spinning so fast in its infancy that our planet could have ejected enough of its own mantle into space to form the moon. Finally, another model theorizes that a nearly identical object to Earth collided with our young planet. And when they smashed together, their chemical compositions mixed to a point where they became indistinguishable from each other. Just goes to show that some of space's greatest mysteries are not far away at all. Thanks for watching this episode of SciShow Space, and thanks to all of our Subbable subscribers who make this channel possible. If you'd like to support us and score some cool gear, go to subbable.com/scishow to learn more. And if you have any questions or ideas for an episode you'd like to see, you can find us on Facebook and Twitter and in the comments below. And if you want to keep getting smarter with us, just go to youtube.com/SciShow Space and subscribe.